Day 30 of doing a LeetCode problem every day until I get a job. All right, guys, we're back at day 30 already. We're almost at a month. What's the day? Today is the 3rd. We started on the 5th. So after tomorrow, tomorrow will be the last day of the month, and we will have been doing a LeetCode problem every day for a month. Now, guys, there's nothing to get excited for because it's only a month, but you could pat yourselves on the back if you made it this far because you haven't stopped yet. And I don't plan on stopping anytime soon. So I don't think you guys should either. We're going to keep going. We're doing a LeetCode problem every day. Another day, another LeetCode problem. So what I need you guys to do is don't forget to like, comment, and subscribe. We're trying to run these subscriptions up. We're trying to run this engagement up, and I need you guys' help. So go ahead, drop that bank emoji in the comments. All my bankers, drop that bank emoji in the comments. Go hit that subscribe button so you don't miss a LeetCode problem either. We're doing it every day. You need it to pop up on your screen. Go ahead and subscribe. Now, with that being said, let's see what question we have here today. Today we have question number 1456, maximum number of vowels in a substring of given length. The difficulty level is medium. So guys, remember this is a sliding window question. We're in the second question in the sliding window portion of the LeetCode 75. So just keep that in mind as we do this question. And remember, it's a sliding window. So let's see what the question says. It says, given a string S and an integer K, return the maximum number of vowels in any substring of S with length K. Vowel letters in English are A, E, I, O, and U. Okay, so let's look at the example. The example 1 says, input S is a string of letters. It said the string is A, B, C, I, D, E, F, and K equals 3. The output is 3. The explanation says the substring I contains 3 vowel letters. So let's see how they got this explanation. Remember, K equals 3, so that's our window right there. What we want to do is find how many vowels we could find in that window. So first the window would be ABC. Or we want to find the maximum number of vowels we could fit in that window. So remember, the first window would be ABC. Then that window would move down and to be BCI. BCI, we got 1 vowel, but we could have more, or we might have more. Let's see, let's check. Slide the window down 3 more. Oh, now we got CII. Oh, now we got 2 vowels. That might be the maximum number of vowels, but we gotta keep sliding the window and see. The next window has III. Oh man, that's 3 vowels in the same window. That's the highest we have yet. So let's see, we have to continue the whole string. So let's keep going. We go down, next window, IID. It's only 2. So right now, the highest is 3 with the III. We gotta slide the window down again. Now it's IDE. And that only has 1 vowel, so still the highest we've seen in the same window is 3. We're going to slide the window 1 more time to DEF, and that only has 1 vowel, which is E. So out of all those times that the window slid down, the highest time was when it was at III, which is 3, which is why the output is 3. So let's look at the explanation. It says the substring III contains 3 vowel letters, which is the maximum amount that could fit in the window. So the output is 3. Even if there was another vowel after this, say it was 4 I's, the output would still be 3 because our window is only 3. So keep that in mind as well. The maximum output should be 3 because the window is 3. It can't be more than 3 because the window doesn't expand that far. So let's look at example 2. So this will be another better example of what I was just trying to say. It says input S equals a string A, E, I, O, and U. K equals 2. Output 2. Now, a lot of you guys might wonder, why is the output 2 when we obviously see 5 vowels right here in the same string, same substring? We don't even need a substring because they're all right next to each other. And that is because K equals 2. So remember, the window is only 2. That's all we could check. You check AE, that's 2. Then you go down, you move the window down to EI, it's still 2. You move the window down IO, it's still 2. You move the window down to OU, and it's still 2. So that's why the output is 2, because the window is 2, and we found everywhere we look, everywhere we move that window, there's going to be 2 vowels. So the output is 2, because that's the maximum that the window allows. Explanation: any substring of length 2 contains 2 vowels. That's why the output is 2. So let's look at example 3 with a little with a real word, where it could get a little bit more confusing, but it's still kind of like example 1. But let's see, I'll show you what I mean. This is input S equals the string LeetCode K equals 3. Output is 2. Explanation: Le, E, and OD all contain 2 vowels. So remember the window. So look, Le, we're going to start with the K equals 3. That means the window, we have 3 letters in our window. We're going to start at the beginning. LEE, that's 2. Boom. So right now, the record is 2. We had 2, 2. We had the most we've seen in one window is 2. We move it down, we have EET. That's 2 vowels. We're still at 2 vowels in the same window. That's still the highest record that we've seen. Then we move it down again. ETC, that's only 1 vowel, so it doesn't, the record is 2, remember. So it hasn't beaten the record yet, so we don't have to worry about it. We move it down again. TCO, that's only 1 vowel. We still ain't beat the record, that's 2, so we're going to move it down again. Now we have COD. Still only 1 vowel. We trying to beat 2, so it doesn't make the cut. We move down again. ODE, it gets to 2, but it doesn't get past 2, so the record stands at 2. And that's why the output is 2, because every time we move this 3-letter window, every time we slide it down, the most vowels we've ever seen in one window is 2, so that's why the output is 2. So now let's see how we are going to code this, though, guys. That's where the fun part is. So let's have some fun. Let's get to coding. So the first thing we're going to do is we're going to say declare a variable called max vowels, and we are going to set that equal to 0. Then we're going to set another variable call that count. We're going to set that equal to 0. Then we're going to declare another variable, call this chars, and this is going to be equal to an array of S. So we're going to break S up into an array so we can examine each element in S and see if there's a vowel or not. Then we're going to come down here and we're going to let the compute, we're going to declare this variable vowels, and what this is going to, we're going to set this as we're going to cast this as an array of characters, and then we're going to set that equal to, and this is where we're going to let the computer know what the vowels are, because the computer is not going to know what a vowel is until you tell it. So this is where we're telling the computer what a vowel is. And so we're going to say A, E, I, comma, O, comma, U. Then we have to do the capital letters too, so we're going to do the same thing over, but all caps. A, E, I, I, O, and U, right? So then, now we know what the vowels are. So now we're going to loop through this array that we have so we can see if it contains any of these vowels. So we're going to say for I in 0 up to chars.count. We're going to come down here, we're going to say if I is greater than or equal to K, because remember, if it's greater than K, it doesn't matter. So we're going to let the computer know what we're going to do that it doesn't matter if it's greater than K. And in order to do that, we're going to say if vowels dot contains chars Then we're going to say I through K. Then we're going to say count minus equal 1. So the computer knows not to count anything after K. Then we're going to come down here, or if it moves, or don't count anything before I, in case the window's in the middle somewhere. Then we're going to come down here and we're going to say if, we're going to say if vowels dot contains chars I, then we're going to say count plus equal 1. So we're keeping track of how many vowels we've seen so far. And then we're going to say max val now equals the maximum max vowels, comma, count. And what we're going to do is we're going to return max vowels. So let's run it and see what happens, guys. Oh, okay. Well, gotta add an S to this, or else it's not gonna work. Let's see, and it's accepted. Okay, let's run it and see what that time is looking like. Trying to see what that time. Okay, 51 milliseconds beats 68.72% of users with Swift. It's alright. Could be better, but it's alright. It's alright. It passed. We made it through. So until tomorrow, guys, I'll see you guys then for some more LeetCode problems.